single allele A and B. When when those members are equal, we are in a situation of equilibrium. But most of the time, we are in a situation of disequilibrium. So basically, this DAB, this distance, it's different from zero. It can be higher or less than zero. And so why it's important to evaluate that this residual linkage disequilibrium on markers? Because it determines the marker density to use. For example, let's suppose a large LD block. It means that we need a low density marker density for our analysis, while a small LD, it requires high density of marker, in particular one marker for each haplotype. And so in genome-wide patterns, the LD is influenced by different evolutionary history. There are selection, genetic drift, and population subdivision that influence the LD, the linkage disequilibrium. So this is the formula that we have seen before, and by this mathematical calculation, there are some constraints that is in particular because it's difficult to compare different marker, because different marker can have different allele frequencies. So it's difficult to have a unique value of linkage disequilibrium from this formula. So many other ways for calculating linkage disequilibrium came out. In particular, we can have the normalized D, where basically we create a D that is normalized, is given by those formulas. In particular, when the linkage disequilibrium between A and B is minor than zero, we use as Dmax the minimum. The minimum Dmax is given by the frequency of the haplotype AB, while if the AB is greater than zero, we have the Dmax is given by the minimum by the frequencies of the recombinant haplotype. Another way is to use R-squared, that it creates a correlation, and basically this R-square range between 0 and 1, where 1 implies that it is a linkage, implies that the markers provide exactly the same information, means that the two markers are in linkage. We can evaluate, for example, two population by linkage disequilibrium and see how the natural population can increase the accuracy of the analysis. In particular, here in this graph, we have in the dashed line, we have a recombinant inbred line population that is given by a biparental population. And here in the continuous line, we have a land races population. So as we can see in land races, the LD drop faster than the recombinant inbred line. So it means that using a mapping population that is that comes from a natural population, we can reduce the extent of the linkage disequilibrium, and that it means a higher resolution on the analysis. So let's start from the first model that we can have for genome-wide association analysis. And in particular, this is a linear model, a regression model, where here, as it was before in the linkage mapping, we have the genetic value and the phenotypic trait. And if we can, we have a significant correlation. Basically, we have the marker that influence the phenotypic trait. But those methods in a natural population, they don't take into account the population evolution history of the current panel that we are using. So it's important to take into consideration, for example, population structure. What is the population structure? The population structure, it's like a population subdivision that come from evolutionary history, and this kind of population subdivision create difference in allele frequencies between subpopulation. And these differences in allele frequencies can create what we call it spurious association, or false positive in the analysis if we don't take it on into account. So let's take a macro example, an extreme example. We have two populations, the blue population and the red population, where in the blue population we have the marker that we have the allele major A and major B that are fixed, and in the red population we have small a and small b that are fixed. If we create an association panel from this sampling from both the population, we create, basically we can see that we can think that AB, the A and B allele are in linkage, in perfect linkage disequilibrium, because we don't see any recombinant haplotype, let's say major A, small b, or small a, major b. So we think that there is a perfect linkage disequilibrium regardless the physical link, the physical closeness between the two markers. So their physical linkage. So basically, it's important to consider the LD because the population and the population structure, because this subdivision of population can create this false positive. But not only population structure occur, we have also family relatedness or kinship. Here, as reported in this paper, basically we can pass from a population that is a panmitic population that with no structure and no family relatedness, and moving toward more structure and complex population where population structure and kinship occur. There are different ways for calculating population stratification by genetic data. There are different programs like structure or admixture, or we can also use a principal component. So using all the marker and putting them in a multivariate analysis like the PCA, we can use the principal component as covariate for correcting for population structure. So let's generalize in the model, figure out the model. We start from the former general linear model, where we have the marker effect that we consider fixed, and the Q, that is the population structure effect, that we also consider fixed. And more complex model are the mixed linear model, where they add a further factor that is the family relatedness, and it's considered as random. So the general output of genome-wide association mapping, it's a Manhattan plot that has here reported in the figure, where we have in the x-axis we have all the genome, and in the y-axis we have the log of the probability, so the significance of the and every dot, it's a marker. So the dot that overpassed a certain line of significance are significantly associated with the trait. So there are different models. There is a mixed linear based model that we have seen before, and these are based on single locus method. So basically, one marker to every analysis. But there are also other type of method that we will try to explain, and that is the multi-locus and the multi-trait method. The multi-locus basically multi-locus mixed model. One example is in literature. It's called farm CPU. Is used when different traits can be associated with the population structure. So an example in plants is like flowering trait that can really be associated with population structure. So in that case, this multi-locus mixed model incorporate multiple markers simultaneously as covariate in a stepwise model. And so with this stepwise process, it can remove the confounding effect of the population structure. Here in this paper, they tested, for example, for Arabidopsis, different method. And as we can see, we have that the farm CPU is this model is the one that has the better prediction. Basically, here all the model here. We have the expected and the observed value expected under the null hypothesis that there is no association. We have that all the markers stands on the line, follow the observed evaluation, and only the markers that are out of that line are the significant marker that goes far over the expected value. Then there are also the multi-trait mixed model. So means that they use different trait, they compare different traits altogether. And this type of models, it's important to evaluate interaction or pleiotropic effect between loci. And so it's an analysis that it can be super useful, in particular now with the precision phenotype given by the transcriptomics and metabolomics. So using this type of approach can be super useful for understanding interaction and pleiotropic between loci. So concluding, in order to assess the genome-wide association analysis, we have to start selecting an association panel, creating from a natural population, and then we have two paths to follow. We have to phenotype the population and create a genotypic data set from genetic marker, and then we can run the genome-wide association analysis. By now, in the 1.5 years of PhD, we created for my project, we created an association panel for chickpea. So we create a population, and this population is currently under the 3rd year of trial, and so we are collecting still phenotypic data for that population, and also we are collecting, we are sequencing this material through whole genome sequencing, and so I will be ready for show you hopefully the result for the genome-wide association analysis. Thank you for your attention.
Thank you, Lorenzo. Very interesting. You give us a good description of this technology, of this genetic approach for studying population and for identifying genes or genetic variation in population. I don't know if there are questions. Some colleagues that have questions. I see some more colleagues now connected. Well, I have, let's say, a general question. Well, it's more addressed to our work. So because, you know, we are working with strawberry, so it's an octoploid. So how far this approach can be transferred easily from diploid or polyploids plants? Is that something that can create a problem, or can be easily transferred? Because, you know, in polyploids, the number of loci is increasing and repeated in different chromosomes, so it's a little bit more complicated. So it's my only question I can give.
No, I got it. For example, for allotetraploid or in general allopolyploid, like wheat, for example, durum wheat or as haploid wheat, there's no problem because the allotetraploid, they behave like the diploid, basically. They while I don't, I have to figure it out better for autopolyploid like alpha, because then we have more allele combination. So for sure there are models that take into account also that. But by now for allotetraploid, for example, the picture that I show for Manhattan plot, that was for wheat. There was the genome A, and you don't see the presentation, right? Or yes?
No, yes, we still see.
You see the presentation?
Yes.
Like here, we have this is the durum wheat, so we have all the chromosome A and all the chromosome, all the genome A and all the genome B. So in that case, for allotetraploid, the model are the same for the diploid.
Okay. Yes. No. So I agree on this. Okay, well, let's, I don't know, thank you very much. If no other questions are coming from colleagues, I want to thank you for your presentation. It's really, again, very interesting, and good luck for the coming here and be straightforward on your work. Okay.
Yeah.
Thank you, Lorenzo. Let's stop and let me see. So we continue now with the normal program. And so the next PhD student, the next seminar is from Giulia Chiaraluce, and in the completely different area, so in the economy area. So the title is Circular Economy in the Agri-Food Sector, a Review. Okay, good morning, Giulia, sorry.
Yeah, no problem, Pro.
Things.
Okay.
Yeah.
Can you see my screen?
Yes, well, yes, very good. Just to say that everybody, that I'm recording the seminar, so I hope that everybody agree. On this point, we can also use, save this file and use this to enrich our web page of the PhD program, if all of you agree. If you disagree, let me know. Okay. There is a question. Sorry, there is a question. Oh no, Chiara Santa Maria. What happened? What happened with the Ryzen? I don't know. Go ahead. Go on.
Can I go?
Yeah. Go
okay.
On.
So I share again my screen.
Yeah.
Okay. Okay. If you can see my presentation. So good afternoon, everybody. My presentation will be centered on the relationship between the circular economy and the agri-food sector, with a particular focus on the food waste generation and valorization. But first of all, I want to remember that this work is part of a project of an innovative doctorate that is sponsored by the Marche region, and the title of my project is properly The Circular Economy in the Agri-Food Sector Post-Pandemic, so post-COVID-19 in the Marche region. So this is the outline of my presentation. First of all, I will introduce you briefly the context in which we are working. Then I will give you some useful definitions to better understand then the bibliographic research that I made, and then the objective, the analysis, and finally the next steps. So one of the main problems of the European Union is the generation of wastes. According to Eurostat, in 2018, 2.3 billion tons of wastes were generated in the European Union. Of them, almost 1% comes from the agri-food supply chain, namely agriculture, forestry, and fishing. The agri-food supply chain produces a large amount of highly pollutant wastes, rich in valuable organic matter and also moisture. Food wastes are generated along the whole food supply chain. They start in the field, where bad weather conditions as well as pests attacks can reduce a lot the quality and the quantity of the raw material that then is transported and stored. During transportation in particular, some mechanical damages can occur, then leads to a reduction in the quantity of the product that arrive to the processing plant. During processing, obviously, we have the removal of non-edible parts, like, for example, kernels or peels for fruit and vegetables, or bones for meat, for example. Also, the process of sorting by dimension, by color, by shape, reduces a lot the quantity of product that then arrive in the distribution and market. At the household level, so during consumption, in the latest stages of the food supply chain, the main problem is related to the discard of still edible food. In fact, municipal solid wastes is a very big deal that is treated not only by the European Union, but also all over the world. Food waste generation has a direct impact on the whole sustainability of the supply chain from an environmental, social, and economic point of view. For the environmental aspect, obviously, if we waste food, we are contributing to greenhouse gas emissions. In particular, in the European Union, almost 6% of the total greenhouse gas emissions are related to agricultural wastes. As well, we are depleting non-renewable resources, like, for example, water, or we are contributing to land scarcity. For the social aspect, obviously, if we discard still edible food, we are contributing to world hunger. For the economic part, if we discard the food or we remove part of the raw material that then should be transformed, we are renouncing to some incomes and revenues for farmers, for stakeholders, but also for consumer. If we are discarding edible food, we are losing the money that we are invested in the supermarkets and in the retailers. This representation of FAO graphically states what I was saying before. So what we see of the food waste is related in particular to the economic aspect and the money loss. But what we do not see is the environmental impact, so loss of biodiversity, increase of water scarcity, eroded land, as well as the volatility of the food prices. So the shift from a linear to a circular model can help a lot in managing the wastes. In particular, the circular economy offers some tools that can enable agriculture to try to deal with all the wastes that are generated. But before going on, we have to make some clarifications in terms of definitions, because in literature there is quite a conceptual confusion regarding circular economy. So circular economy is the same as bioeconomy or green economy. Also food waste, food loss, what they mean, and byproduct. So starting with the work by Kircher and collaborators that studied 114 different definitions of circular economy, circular economy means many different things to different people. For some authors, the circular economy is just a new economic model, while for others is a way to try to fight the problems that we can find in the environment. For others, again, we are treating with social problems. But luckily, the European Union gives us a hand, because in 2015, the first Circular Economy Action Plan was released, and the European Parliament gave us the official definition of circular economy. Circular economy is a model of production and consumption that is based on the so-called 3R principle, so reduction, reuse, and recycle, in order to retain as much as we can materials and products in the production system, in order to create further value and try to reduce the waste to a minimum. But we have to remember that circular economy is not a synonym of sustainability, because while circular economy is a regenerative system or a model, sustainability is a paradigm, so means the balanced integration of economic performance, social inclusiveness, and environmental resilience in order to try to bring benefits not only to us, but also to future generations. So we can see that circular economy is a big part of the so-called sustainable development. But also, circular economy is not a synonym of bioeconomy or green economy, because the green economy is based on the use of regenerative, renewable resources in terms of materials and energies for the production system. So bioeconomy can be a part of the circular economy, but they're not the same concept. For the waste part, I want to refer to the Waste Framework Directive of 2008. So the directive gives us the definition of waste. That means any substance which the intent is to be discarded. So it has no more value and it cannot be used inside the production line. Regarding the food waste is any kind of food as defined by Regulation 178 of 2002, the so-called General Food Law, that the Article 2 states that food is any kind of substance that should be, it is intended to be consumed by human, that has become waste. But this kind of definition is quite wide, too generic, so we can refer also to bio-waste. Bio-waste is any kind of green waste that comes from parks, from greeneries, gardens, as well as food waste from kitchens, at household levels, from canteens, from restaurants, as well as comparable foods, comparable wastes from food processing plants. But for our purposes, it is important also to understand the concept of byproduct. Byproduct is a substance that is the result of a production line, the primary aim of which is not the production of the substance itself. So in simple words, if we have a milk processing plant, so we want to produce cheese, obviously milk is transformed and then we obtain mozzarella, parmigiano, whatever. But during the transformation, we will obtain also whey. Whey is not a waste because it has a further processing to produce ricotta. So a byproduct is something intermediate, so it is not the primary, but is not also a waste. In literature, the situation actually is simpler, because if we follow the example by Parfit and collaborators, we have only two kinds of wastes, the food loss and the food waste. They are also the official names that are used by FAO, for example. So food loss is any kind of decrease in quantity or quality of food that occur during the early stages of the production, so in the field, during transportation, and in the production process. While food waste are those reduction in quality and in quantity that occur in the latest stages of the supply chain, so retails and at household level. The main difference also is that while food waste in most of the cases are avoidable and intentional, food losses are not. So in most of the cases depends on, as I said before, pests attacks, for example. Also, food loss are mostly distributed and present in developing countries, while the food wastes are more diffuse in developing countries. So I have to say, for the sake of this work, that generally in literature, what we use most is the general term food waste. So we will refer to any kind of waste that are produced in the field, in the production process, and at consumption level as food waste. So the objective of my bibliographic research was try to understand the paradigm of the circular economy applied in the agri-food sector, with, as I said, particular focus on the recovery and valorization of food wastes. But I have to say that this kind of study has a small limit, because obviously, even if the waste part represents one of the main parts of the circular approach, obviously it is not the only thing that we can say about this kind of new model. Obviously depends on the type of process that we are dealing for, because obviously we are in food, so we cannot talk about repairing food to remit it in the production line. But we do not only limit the application of the circular economy to this part of the production line, so the final part of the production process. So the bibliographic search started with these keywords, so circular economy, food associated with waste and byproduct, agriculture and agri-food. The research produced 125 papers, both in Scopus and WAS, that then were screened and analyzed in order to understand the most productive countries, the years of publication, the research areas, the most important papers in terms of citations, and finally, the main themes of research. So for the year of publication, we can see that using that particular combination of words, the first article that I was able to find was in 2014. Then we can see an exponential increase, in particular starting from 2017, with an increase of more than 500% in terms of scientific publication. Obviously, you can see that for 2021, we are still at 17, but because my search stopped in March 2021. In terms of most productive countries, Europe is on the top of the list. In particular, Italy, Spain, and the United Kingdom occupy respectively the first, second, and third position of the chart. This is not surprising, because the concept of circular economy was born in Europe, in particular in the United Kingdom, at the end of the 1960s. But it is notable that countries like China, for example, that has implemented its future economic policy starting from 2002 on the circular economy to reach a complete circular system within 2050 is not on the top in terms of research, while Europe, that has started to effectively apply the circular paradigm and the sustainable development paradigm, not only with the Circular Economy Action Plan, but also with the Green Deal or the Farm to Fork strategy, is on the top of the list in terms of the research. Regarding the research area, we can see that on the top three list, agriculture, that is the focus of my research, is only at the third position. This is because most of the work nowadays is centered on the possibility, on the technological possibility to exploit the residual biomass for further purposes. So this obviously opens up a big gap in the research that we can exploit, because not only agriculture, but also the economic part that is not present even in the top 10 list, obviously is an open door for us to continue as our work. In terms of most important papers, the top one is an Italian paper, and it is also of 2014. So even before starting with the Circular Economy Action Plan, we already have some publications that refer to the necessity to reuse this kind of wastes in a circular approach. And is in particular by Mirabella and collaborators on the valorization of wastes from different origins, fruit, vegetables, meat, miscellaneous, etc. Then we have some other papers that regards the use of wastewaters. That is one of the biggest deal in not only Europe but all over the world, because wastewaters are highly pollutants, so cannot be used as they are in agriculture. Then we have other regarding the energy, so the possibility to obtain renewable energy from the residual biomass. And then the last one by Zucchelli Previtali is the only one that deals actually with economic topics, so the definition of new circular business models. For the themes of research, we can see that around the concept of circular economy rotate a series of different topics, starting obviously with the production of renewable energy, so starting with the biomass through process of pyrolysis or anaerobic digestion, we can obtain biodiesel, biogas, biomethane, biohydrogen, and so on and so forth. Then we have the recovery of phosphorus from wastes, because phosphorus is on the top list of the European Union for the non-renewable substrate, non-renewable resources for agriculture. Then we have the use of biomass for as a livestock feed, in particular for insects like Tenebrae molitor or Hermetia illucens. And then we have the recovery of highly nutritional compounds like antioxidants, like polyphenols, for example, from wastes. And if we see the evolution over time of the different topics, we can see that we have started with agriculture, the proper agriculture, so phosphorus, food waste, sustainability, and then shifting to a sustainable development and the concept of biogas, we arrive, as I said before, to the recovery of bioactive compounds, in particular from vegetables and fruit scraps. So most of the studies are concentrated on pomegranate, for example, or olive leaves, or even small red fruits. So the next steps of my research will be, first of all, to analyze the policies and the regulations regarding circular economy and bioeconomy in Italy and in Europe, making some comparison, in particular with outbound countries, like, for example, as I said, China, that is on the top in terms of real application of circular economy. Then, obviously, it will be necessary to try and understand which real concrete type of wastes we have available, so vegetables, fruit, meat, the receptor, fish, etc., without leaving apart the agricultural wastes like straws and manure, for example. Then it will be necessary to implement a way to measure wastes in order to develop some regional, some case studies to on market region companies in order to develop and to implement real, concrete circular economy paradigms. So this is my references, and thank you for the attention.
Thank you very much for your presentation. I don't know if there are some questions on colleagues that are connected. Well, from my side, first of all, thanks for clarifying at the beginning all the terms, because sometimes also for me it's very difficult to understand what the meaning of sustainability or sustainable agriculture and circular economy and bioeconomy and so on. So I think that you gave us a very nice description of how these different terms are connected. And well, I have well, you mentioned all the different type of product, and it's clear that you also consider the quality. But in my opinion, I think that one issue is also really how to control the quality of the different product, because then you say, I know, product that can be a source of nutritional compounds and so on, but then you need to see how far this source is appropriate, not contaminated, or eventually really appropriate for such kind of destination. Now, do you know about some kind of methods for controlling or for kind of system for determining the quality of this different type of waste, and see how this different type of waste can be used more properly?
Okay, I think that as for final products, the quality of the waste strongly depends also on the quality of the raw material. So obviously, if the raw material is good, the quality of the waste is good. But then it will be essential to, first of all, have a preliminary step in which we analyze a small part of the waste in order to understand if effectively we can have an activity of that waste. Because, for example, if we talk about small fruits, small red fruits, obviously the discards are really rich in polyphenols or vitamins, but also how much of that waste is available and how much will be necessary to have active compound that then I can use, for example, for fortification of snacks or medicines or nutraceutical, that is one of the main avant-gardes in terms of recovery of waste. So maybe also one of the most important things is not only the quality, but in particular the quality, because if we talk about olive pomace, we have a huge amount of olive pomace, but only during a specific period of time in the year, that is in October, November, we can say. So it will be useful to try to recover that waste if that waste is available only in that period. So these are further steps that will be to need to be assessed maybe later. But now the problem is that they are only focusing on small quantity and validation in the lab if that molecules is good or not.
Well, that is for the beneficial things, but from the other side, I think
for the energy, the problem are the regulation, because we all know that European, but in particular Italian regulation are quite complex. So there is a decreto ministeriale, so ministerial decree that try to sort all the different kind of byproducts. But then if we have a look at that decree, sometimes there is one article that say the opposite of what the other articles say. So in most of the cases, it's necessary an interpretation and asking directly to the minister if that is a byproduct or simply a waste.
Okay. Well, at the end, there is to use it for making organic products, so like organic fertilizers. But then even there, I think that it's important to have some kind of controls.
Yeah. In particular for wastewaters, for example, because we cannot simply use the waters that come from agriculture, because even if they come from agriculture, they are highly pollutants for the soil. So obviously we cannot use them as they are. So.
Well, okay, very complex things. Thank you very much. Thank you. Good luck also for your next period of your beginning. So go on and focus on your work.
Thank you very much.
Thank you, Giulia. The next speaker should be Giacomo Staffolani. Are you there, Giacomo? Yes, I see you. So you can start sharing your presentation towards sustainable dairy supply chain, state of the art in literature research verso una filiera lattiero-casearia sostenibile e stato dell'arte nella ricerca lattea. Decidi tu se in italiano o in inglese.
Proseguirò in italiano per la presentazione. I'm sorry with the English speaker. For the next seminar I will speak in English. Bene, quindi il seminario sarà così composto. Inizialmente vi esporrò l'obiettivo su cui è basata la ricerca. Successivamente effettuerò un'introduzione sullo stato attuale della zootecnia da latte. Vi presenterò i dati che ho rilevato dalla mia analisi letteraria e infine esporrò i prossimi passaggi della ricerca. Innanzitutto l'obiettivo che mi sono posto è stato quello di definire lo stato attuale della ricerca in merito alla sostenibilità della filiera lattiero-casearia, con particolare attenzione alla zootecnia da latte montana. Ho deciso di concentrarmi sulla zootecnia da latte montana perché questa rappresenta la principale tipologia di zootecnia presente nelle zone montane e soprattutto in molti casi la principale fonte di reddito per le zone montane e quindi è un settore molto importante. Tuttavia questo settore negli ultimi anni sta affrontando una forte crisi. Infatti possiamo osservare dal grafico in presentazione una netta riduzione sia nel numero di aziende, che nel grafico è rappresentato come la riga, che sono ridotte del 68%, sia nel numero di capi, che nel grafico è rappresentato come l'istogramma, che dall'82 al 2010 si sono ridotti il 25%. Questi dati sono stati ricavati dall'analisi intercensuaria effettuata dall'Istat e sono rivolti principalmente al mercato italiano. Passando invece ai dati specifici per singoli capi elevati, singole tipologie di capi elevati, osserviamo come questa riduzione è presente sia nei bovini, sia negli ovini, sia nei caprini. In particolare, negli ovini possiamo osservare una riduzione del 69% nel numero di aziende e del 28% nel numero di capi. Negli ovini possiamo osservare una riduzione del 66% nel numero di aziende e del 25% nel numero di capi, mentre nei caprini osserviamo una riduzione del 69% delle aziende e del 12% nel numero dei capi. Questa drastica riduzione ha comportato un forte aumento del numero di animali per allevamento, sta comportando un aumento dei sistemi di produzione indoor a discapito dei sistemi di produzione estensivi, sta comportando la sempre maggior diffusione di bovini specializzati a discapito dei bovini autoctoni, ma soprattutto sta comportando un progressivo abbandono dei prati e dei pascoli a favore dell'utilizzo della mangivistica, come ad esempio l'Unifeed. Oltre a questi problemi, la filiera zootecnica da latte deve affrontare ulteriori criticità e sfide, quali la volatilità dei prezzi, le caratteristiche strutturali delle aziende, il rapporto tra la redditività e i costi di produzione, il cambiamento climatico e il comportamento dei consumatori. In particolare, per quanto riguarda la volatilità dei prezzi, questa è legata al cambio di politiche che in Unione Europea abbiamo assistito per l'allevamento zootecnico ed in particolare all'abolizione delle quote latte, avvenuta definitivamente nel 2015, che ha aperto il mercato europeo al mercato internazionale, rendendo così i prezzi meno stabili durante l'anno. E da diapositiva possiamo vedere come i prezzi oscillano tra i 40 e i 25 centesimi al litro durante l'anno, rendendo quindi difficile una gestione sostenibile delle aziende. Per quanto riguarda invece le caratteristiche strutturali delle aziende, sappiamo benissimo che le aziende zootecniche di montagna sono fortemente diverse dalle aziende zootecniche di pianura. Queste infatti tendenzialmente presentano pochi giovani, sono più diversificate rispetto alle aziende zootecniche di pianura, tendenzialmente presentano allevamenti estensivi, anche se come abbiamo visto precedentemente questo aspetto sta cambiando nel tempo, e sono aziende di piccole dimensioni, quindi difficilmente riescono a effettuare investimenti per apportare innovazioni, mentre le aziende zootecniche di pianura tendenzialmente sono aziende altamente specializzate, presentano allevamenti intensivi e sono tendenzialmente allevamenti di grandi dimensioni, quindi hanno potenzialmente la capacità di apportare innovazione, ma essendo altamente specializzate sono più suscettibili rispetto alle aziende montane alle fluttuazioni nei prezzi del mercato. Un aspetto molto importante è il rapporto tra la redditività e i costi di produzione. Infatti le aziende zootecniche, e in particolare le aziende zootecniche da montagna, presentano elevati costi di gestione e questi costi sono strettamente legati al costo del mangime, che negli ultimi anni è in costante aumento. Questo comporta un prodotto lordo vendibile basso e un costo di remunerazione insufficiente. Vediamo infatti dall'esempio molto schematizzato nella slide che se il costo della vendita, quindi il ricavo dal latte e altre entrate che potrebbero essere rappresentate ad esempio dalla PAC, è di circa 70 euro, i costi totali per la produzione di 100 litri di latte si aggirano intorno ai 58 euro e quindi il reddito netto per 100 litri di latte è di circa 9 euro. Se a questi però andiamo a togliere il costo della manodopera familiare, che è di circa 19 euro, vediamo come l'utile netto per la produzione di 100 litri di latte sia in negativo e quindi questo tipo di produzioni non comporta un guadagno per l'allevatore. A questi problemi negli ultimi anni si è aggiunto anche il problema del cambiamento climatico. Infatti le aziende, e in particolare gli allevamenti, si sono ritrovati all'interno dell'occhio del ciclone per queste tematiche, perché incolpati di essere tra i maggiori produttori di gas serra. Tuttavia, oltre ad essere incolpati come tra i maggiori responsabili, le aziende sono anche tra chi ne soffre di più per colpa dei cambiamenti climatici. Perché? Perché gli eventi atmosferici e estremi sempre più diffusi stanno causando enormi danni sia ai pascoli che alle produzioni mangimistiche. Ricordiamo ad esempio la fodder crisis avvenuta nel 2018. In ultimo, la produzione zootecnica deve anche accompagnare quello che è il comportamento dei consumatori e andare ad accontentare la domanda dei consumatori in evoluzione. Da questo punto di vista la zootecnia montana si trova avvantaggiata rispetto alla zootecnia di pianura, perché i consumatori richiedono un prodotto di alta qualità che la zootecnia montana è in grado di fornire, elevati standard ambientali che sono tipici della produzione montana, ricordiamo ad esempio gli allevamenti estensivi, il benessere animale, anche questo tipico della produzione montana, ad esempio legato al pascolo, e la tracciabilità. Questo è l'aspetto forse più dolente per la produzione montana, ma negli ultimi anni, soprattutto anche grazie a politiche gestite dall'Unione Europea, si sta lavorando su questo aspetto. Ad esempio è importante citare il label prodotto di montagna, recentemente inserito dall'Unione Europea, che permette di identificare ai consumatori la produzione di montagne sugli scaffali. Quindi, partendo da questi problemi, ho deciso di effettuare un'analisi bibliografica sulla sostenibilità del settore zootecnico da latte in area montana. Innanzitutto sono andato a identificare quali sono in letteratura gli aspetti della sostenibilità che sono stati presi in considerazione. E i principali aspetti per quanto riguarda la sostenibilità economica sono la diversificazione all'interno delle produzioni zootecniche, la produzione di qualità e la redditività. Per quanto riguarda la sostenibilità sociale troviamo l'autosufficienza mangimistica, l'età degli allevatori, la successione intergenerazionale, la formazione degli allevatori, il turismo e il consumatore, mentre per quanto riguarda la sostenibilità ambientale troviamo aspetti legati al benessere animale e ai servizi ecosistemici. Servizi ecosistemici come potrebbero essere ad esempio la biodiversità animale o vegetale, oppure la capacità di catturare l'anidride carbonica dall'atmosfera, ad esempio dei pascoli. Da questa pre-analisi sono risultate alcune criticità. In particolare, la più importante è che mancano studi approfonditi che vadano ad analizzare tutti e tre gli aspetti della sostenibilità, mentre sono presenti soprattutto studi che approfondiscono singoli aspetti ed in particolare singoli aspetti legati alla sostenibilità ambientale. Quindi sono necessari studi che vadano a raccogliere le tre dimensioni della sostenibilità per dare una più chiara idea di come le aziende dovrebbero comportarsi per mantenere una produzione sostenibile. Per questo motivo sono andato ad effettuare un'analisi di letteratura, andando a cercare nei principali motori di ricerca scientifici come WOS e Scopus con le seguenti parole chiave: sostenibilità, lattiero caseario e montagna. Dopo un'accurata selezione, da questa analisi ho potuto identificare 43 articoli validi. Gli articoli sono stati pubblicati soprattutto in area europea ed in particolare in Italia, Spagna e Francia. Questo perché? Soprattutto grazie alle caratteristiche orografiche di questi paesi. Infatti, sia in Italia che in Spagna che in Francia, le zone montane rappresentano gran parte del territorio. Inoltre, però, è molto importante anche considerare le politiche che l'Unione Europea ha intrapreso per valorizzare le zone montane. Ricordiamo una su tutte il label prodotto di montagna, che accennavo anche prima, che ha messo, diciamo, un faro su questo tipo di produzioni. Alcuni paesi hanno aderito a questa iniziativa e hanno a livello ministeriale rilasciato il label per i loro paesi. Uno su tutti l'Italia, e questo qui è quello che possiamo vedere in slide, è il label prodotto di montagna italiano. Passando invece all'analisi della qualità delle pubblicazioni, notiamo come la maggior parte delle pubblicazioni attraverso lo Shimago Index rientra nel livello Q1 o Q2. Questo sta a indicare non solo che la qualità delle pubblicazioni riguardanti la sostenibilità della zootecnia montana è elevato, ma anche che c'è un particolare interesse per la comunità scientifica per queste tematiche. Passando invece al numero di pubblicazioni per tematica per anno, notiamo come inizialmente veniva studiata soprattutto la sostenibilità ambientale, mentre negli ultimi anni sono aumentati notevolmente gli studi che trattano la sostenibilità economica e la sostenibilità sociale. Questo potrebbe essere legato alla maggiore sensibilità a livello sociale per queste tematiche e il maggiore interesse per la comunità scientifica. Oppure potrebbero essere legate anche all'effetto delle politiche dell'Unione Europea per la valorizzazione di queste aree. Dalla mia analisi è risultato che per quanto riguarda la sostenibilità economica sono stati analizzati soprattutto gli aspetti legati al valore aggiunto dei prodotti e alla redditività delle produzioni. Per quanto riguarda la sostenibilità sociale sono stati analizzati soprattutto il rapporto dei consumatori nei confronti dei prodotti di montagna, mentre per quanto riguarda la sostenibilità ambientale sono stati effettuati soprattutto studi sul bilancio dei nutrienti nel suolo, sulla gestione dei reflui e sulle emissioni di gas serra. È interessante notare come ci sono aspetti che vanno a raccogliere diversi aspetti della sostenibilità, in particolare il valore dei servizi ecosistemici, che è comune sia alla sostenibilità economica che alla sostenibilità ambientale, e la relazione degli utenti con i servizi ecosistemici, che è comune sia alla sostenibilità ambientale che alla sostenibilità sociale. Da questa analisi letteraria sono risultati, dopo aver effettuato questa analisi letteraria, è risultato necessario andare a definire quali sono i passi successivi. In particolare sarà necessario andare a effettuare un'accurata analisi delle politiche europee per la valorizzazione delle zone di montagna, per andare anche a vedere gli effetti delle stesse, un'analisi del settore, in particolare un'analisi di mercato, per vedere come questo si è evoluto negli anni, un'analisi della sostenibilità della filiera lattiero-casearia, come accennavo prima, tenendo in considerazione tutti e tre gli aspetti della sostenibilità, e quindi magari andare a effettuare un'analisi costi-benefici, ed infine andare a effettuare un'analisi al consumatore, per andare a vedere se effettivamente le produzioni di montagna riescono a soddisfare la domanda del consumatore e quindi se possono avere futuri sbocchi nel mercato. Questa è la mia bibliografia, grazie per l'attenzione.
Grazie a te, Giacomo. Non so se ci sono richieste, domande da parte dei colleghi. Inviterei i colleghi ad essere un attimino più presenti anche in questa cosa. Una domanda bisogna sempre farla, quindi se non ci sono colleghi cerco sempre che vogliono intervenire.
Io Bruno, no, siamo un po' troppo lontani dalle mie cose, insomma, la farei volentieri. Ero qui attento per vedere di trovare qualcosa che fallisse della presentazione di Giacomo, non ce l'ho fatta, mi perdonerai.
No, ma non che fallisse, dai.
Sì, ho una curiosità, certo.
Allora, visto e considerato che tu sei lontano, Giuseppe, io sono tantino più vicina come argomento, e devo dire che un pochino mi ha spiazzato la storia della sostenibilità ambientale, per il fatto che la definizione di sostenibilità ambientale è una definizione molto precisa ed è in termini di valutazione di emissioni. Quindi non ho capito se hai intenzione, e la cosa sarebbe molto, molto interessante, soprattutto molto ambiziosa, di trovare un indice che riesca a mediare degli indici molto, molto oggettivi, come sono quelli di sostenibilità ambientale, con indici molto meno facili da definire, come sempre in termini ambientali possono essere degli indici legati alla biodiversità, alle condizioni ecologiche e via dicendo. Non ho capito, hai intenzione di fare anche questo, Giacomo?
Allora, nella mia ricerca futura in realtà avrei intenzione di andare a implementare agli indici, per l'appunto, che vanno a analizzare la sostenibilità ambientale, anche indici che permettano di prendere in considerazione gli altri aspetti della sostenibilità, quindi della sostenibilità economica e sociale. Perché? Perché la sostenibilità ambientale in realtà è molto importante, ma non è l'unico aspetto, è fondamentale diciamo, ma non è l'unico aspetto da tenere in considerazione. Perché, come dicevo, una criticità, ad esempio, nella zootecnia montana è il rapporto tra costi e ricavi. E questo rapporto rientra all'interno della sostenibilità economica. Se l'agricoltore non si trova in condizioni di poter svolgere l'allevamento in condizioni economicamente vantaggiose, non si ritrova neanche in condizioni di poter seguire gli obiettivi della sostenibilità ambientale e quindi si va un po' a perdere il tutto. Quindi è importante tenere in considerazione tutti gli aspetti. Quindi sì, uno dei miei obiettivi è quello di trovare degli indici che però riescano a integrare agli aspetti della sostenibilità ambientale anche gli altri aspetti. Quindi sì, è abbastanza complesso, però sto lavorando su questo e spero di riuscire.
Va bene, grazie.
La ringrazio.
Grazie Esther, ma penso che sia veramente un aspetto fondamentale questo, perché le prime slide con quei grafici che facevano vedere quei cali così evidenti, cioè, per carità, poi la gente adesso diventa tutta vegana e quindi non mangia più carne, non lo so.
No, non mangia più neanche formaggio, quello è il guaio.
Quello è il problema.
Però in realtà io rimango sicuramente dal lato dei cammini. Però ecco, mettere insieme queste cose la vedo abbastanza complicato come impostazione, però credo sia importante anche perché poi molte delle politiche, delle idee, delle strategie sono quelle di sviluppo nelle aree montane e così via, però poi se non si portano delle soluzioni di reddito diventa abbastanza difficile pensare che ciò avvenga.
Grazie.
Grazie a te. Se non ci sono altri commenti ci fermiamo con Giacomo, ben arrivata anche Stefania. Io man mano che arrivano i colleghi giro le schede.
In realtà io c'ero.
Ah, non ti avevo visto, scusa.
Però
Giro le schede di votazione.
non avevo parlato.
Giro le schede di votazione così che contribuite alla valutazione.
Sì, ho sentito anche il precedente seminario.
Sì, no, quelle compilate le schede per i dottorandi che avete seguito. The next is Sara, let me see better the name, Sara Mogela Macao, that is Education and Social Family, Mental Disorder. I don't know if Sara is now connected. Yes, Sara, nice to see you.
Nice to see you. Thank you.
Okay, you can share your screen and start your presentation.
I am sharing now. It's still loading.
Okay.
I need a bit of help. It is not showing on the screen. My presentation is open, but when I say share, it doesn't come up. Where do I go? I see the PowerPoint live, but my PowerPoint is not there.
No, you need to share, to use the option share, so the
yes, I have clicked on the share option.
Go and move and put in your screen, in the full screen, the presentation, the PowerPoint presentation.
Perché l'economia, no?
Sì.
Yeah.
Are you able to see it now?
Yes. Okay. Full screen. Open the full screen.
Are you able to see the full screen?
Not yet.
Is it okay now? I think the full screen is okay now.
No. Yeah. No, it's not. If you are working with Apple, maybe that is a problem. Well, go ahead. Go ahead.
It's not Apple. On my side, it's full screen.
Here, at least on my side, I don't see as a full screen.
Should I go ahead?
Yeah, go ahead.
Okay.
Good afternoon, everyone, and thank you for the introduction for my seminar, which is going to be on education in social farming with a focus on mental disorders.
Education in social farming.
Focusing on mental disorders.
Beppe, spegni il microfono.
Scusa.
See, it's okay. The presentation is moving now. In the past years, there's been a rise in mental disorders. Which
Sorry,
is
but Sarah, but it's not going on. You are still in the. We now see.
It's still in the first slide.
In the first slide, yes. Now, okay. Okay.
Now did it move? I went out of the full presentation to.
Okay, go ahead like this.
Like this.
Yeah.
Okay. There has been a rise in the number of mental disorders over the past years, which is seeming to have significant impacts on the health and major social, human rights, and the economy. Mental disorders can be referred to as a wide range of conditions that affect mood, thinking, and behavior, and they can either present as occasional or chronic. And such disorders include depression, bipolar disorder, schizophrenia, and other psychosis, as well as dementia and other developmental disorders. In the world, there's an estimated 264 million people who suffer from depression, of which a majority of those is women compared to men. And there's another approximate 50 million people who have dementia, as well as an additional 20 million people who have schizophrenia or other psychosis in the world, which can present itself in late adolescence or in early adulthood. There's also developmental disorders, which include intellectual disabilities and developmental disorders such as autism. And intellectual disabilities describe a wide range of neurodevelopment disorders that can impair both intellectual and adaptive functioning, which can have problems in later years for the social or practical skills of a person. And these intellectual disorders can present themselves during childhood and they can persist until adulthood. And looking at the type of mental disorders, we have so far looked at depression, and there's also anxiety, which affect an approximate number of 284 million people in the whole world. There's eating disorders such as clinical anorexia and bulimia, which affect 16 million people in the world. There's mental or substance abuse disorders affecting 970 million people. Alcohol use and drug, which individually affect 107 million people, as well as 71 million people respectively. And it can be noted from this table that majority of these disorders are seeming to affect more females than they do males. It's only in the three, which is alcohol use and drug use, as well as schizophrenia, where males are affected more than females. And the mental disorders can have economic impact in the world or in the specifically in Europe. For my focus, I chose to focus on Europe. And looking at this graph that was done by the OECD in 2018 using data from 2015, it can be noted that Italy has 3.3% of the GDP being put towards mental health problems. So the cost is 3.3, which is comparable to that of Europe, which is 4.1. And in looking at this graph, we can say Italy is doing more or less better than the whole of Europe combined in terms of not losing too much towards mental health, but this number on its own is still very large. And we can also have a look at the impact of mental health disorders on the general years of life that one is expected to live, which is the contribution of the mental health to disability adjusted life years, which is described as the number of years lost due to ill health, disabilities, or early death of an individual. But in this case, the results were combined into both sexes, both females and for males. And it can be observed from the graph that disorders are contributing significantly to the disability adjusted life years. It is not just a matter of someone suffering from a mental illness and living throughout their lives with it. It can actually affect or have an impact on the number of years they have on this earth. And the current challenges that we are facing now is that there's more than 70 people, 75% people with mental illness in less developed countries, or worse, in rural areas, do not receive mental health treatment. And this can be due to a number of factors or a number of reasons, which are not limited to the stigma associated with mental illness, the lack of trained clinicians, or the lack of resources that are available for the trained clinicians that we have currently. And so a growing number of the mental disorders implies that we need to make necessary adjustments to make available training for professionals in the field, as well as to identify additional resources that can be used in the recognized cases in the population. And therefore, investment in mental health is a matter of cost effectiveness, social justice, and a smart development strategy. And one of the solutions that has been put forward and has been gaining momentum in the recent years is the use of social farming. Social farming is based on the concept of multifunction agriculture and community-based healthcare. It describes use of various agricultural activities that focus mainly on the social needs of people, which can include rehabilitation, sheltered employment, lifelong education, as well as intervention that are meant for social inclusion. The agricultural activities can include horticulture, food processing, selling of products, and animal care, and the management of farm restaurants. And as such, the environmental factors can play a fundamental role in mental illness prevention and mental health promotion. There is a regulation that was put forth in the year 2015 called the National Law on the Provisions of Social Agriculture, which came into effect on the 23rd of September in 2015, which effectively gave legitimacy to the existence of social farming, and is meant to promote social agriculture as an aspect of multifunctionality of agricultural enterprise, which is aimed at the development of social health, educational, and social work integration, intervention, and services. This is supposed to facilitate the adequate and uniform access to essential services so that individuals, families, and communities throughout the national territory, and in particular in rural areas, can be guaranteed services that are useful for their needs. And looking at social agriculture, it encompasses a wide range of different professions or professionals. We can say farmers are well equipped with the working of a normal farm, as well as other associated agricultural personnel. And mental health experts are well within the mental field. They know what mental health is, and they know how to approach people who suffer from mental illness. And there's non-mental health specialists who work in related areas but do not have both the knowledge of the mental health or the farming part. And there's other people who are interested, who might be interested in engaging in social farming. So as a result, having a comprehensive education and training resources in social farming will be able to benefit all the interested stakeholders so that they can be taught the correct tools to use when engaging with clients in their different facilities, as well as to familiarize those that do not have an agricultural background with the setup of what happens on a farm, the day-to-day runnings of it, so that in all completely in its entirety, they can be able to provide superior mental health interventions to all their clients so that they can improve individual and community mental health and health in general. And as such, it is proposed that there be a comprehensive education and training curriculum. And when looking at literature, there is a training program or a project that came about from taking points and various points from other projects that have been running for a couple of years. This new project is called Inclufa, and it was born due to a lack of standardized and quality control teaching curriculum in social agriculture. They took various points from one project called the Expert for Social Farming and Inclusion, which is a training concept that has been practiced for a number of 12 years, and it has been accredited by the Schleswig-Holstein government, and it's accredited along with other social professions. And this training program can be carried on for a number of 3 years, the whole curriculum. And there's also the Baltic Seminar, which also takes 3 years. It's a training program for 3 years, which was developed for experts working in the area of social farming, mainly targeted for trainees from Norway, Estonia, Finland, and Russia. And from these two projects, it was born the INCLUFA, which is the Inclusive Farming Curriculum. And there's also the Diana project, which is the Disability in Sustainable Agriculture, which was dealing with the demands of practitioners from various professional backgrounds working on social farms. During this project, training tools were developed and tested as a piloting on social farms. An additional project that was studied is the MAI project, which is the Multifunctional Agriculture in Europe, which aimed at developing a curriculum for farmers who were interested in engaging in social farming. And all of these projects were supported by the European Lifelong Learning. And as a result, in recent years, in the year 2019, there was a program called the Social Farming in Higher Education, for short, SOFA Education, which is an international project aimed at creating transnational higher education and curriculum and teaching material for the field of social agriculture, which aims at teaching students social work, agriculture, and farm entrepreneurship. And the project was created amongst 5 countries, which is Austria, Germany, Norway, Czech Republic, and Hungary. And from the project, it was proposed a curriculum for teaching social farming with a couple of units that make up the whole curriculum. The first unit is the introduction of social farming, basically looking at why social farming exists, what is it important for, and how is it going to benefit the community at large, and why, as a farmer or as any other profession who want to go into social farming, why did you choose to focus on this particular branch of agriculture? What interests you, and what legal issues can you go through when you are engaging in social farming? And they teach you also about finding fundraising for your social farm, financial issues. Unit 2 will be focusing on the basics in social agriculture, basically introducing the works of social agriculture, both in theory and the methods, and the ethics for helping professions. They will also be focusing on the psychology, sociology, and social pathology, so that everyone who's doing this course will know all the mental disorders or all the social difficulties that plants who engage in social farming go through. There's also Unit 3 that focuses on the basics of agriculture, because as much as this is going to be focusing on people, we still need the whole agricultural setup to be running as perfectly as if it would have been for a commercial farm. So they will be teaching agriculture, basics in soil science, crop production, animal production, and so on and so forth. And there's also a unit which is going to be focused on the target groups on social farms, which is going to be teaching communication and conflict management, as well as the knowledge on target groups, because it has been noted that people suffer from different mental disorders. So you need to be taught how to deal with each case as it comes, per mental disorder, per target group, and also on an individual level. So you need to learn how to interact with the people, how to communicate with them, and how to resolve conflicts if they may arise. And there's Unit 5, which is going to be based on the adaptation of a farming activity and farms to social farming. Because the whole concept of social farming does not always start up from a farm that is new going into social farming directly. Most farms start as conventional farms and they are converted to social farms. And as such, people need to know how to go about converting a normal commercial farm into a social farm. And there's a Unit 6 which focuses on entrepreneurship. We have stated that the farm is going to be run as a normal farm, but with a more social aspect to it. But there's still the need to focus on the business side of it so that you can keep the finance of it moving, so you can be able to sustain the farm. So this unit on entrepreneurship is going to be focused on the financial aspect of the business, marketing and the communication, as well as the business plans as a whole. And Unit 7 is going to be based on the farm placement and field trips. And finally, we are going to have Unit 8, which is going to be the conclusion of the whole curriculum with a thesis and a seminar so that people can be certified as social farm experts. And currently in Europe, there are several universities that offer social farming at tertiary level. The first one we're going to focus on is Land and Agricultural Science curriculum for social farming at the Marke Polytechnic University, which was started in 2015. And we can see from this table that in the first year, there is a course in social horticulture that is focused more on the social aspect, social farming aspect of the whole concept. But on year 2, we have quite a number of courses that focus on social farming, being well-being and development in social farming, psychosocial impairments and prospects for social inclusion, as well as animal production and social agriculture, all of which give 6 credits in total, except for the first year course, which has 9 credits in total. And there's the animal production science and technologies from the University of Pisa, but with a curriculum that focuses on agriculture, on social farming, being agro-zootechnical, multifunctionality, and human-animal interactions. On the first year, there is no subject that focuses on social farming, but on the second year, we can find 2 courses, being multifunctionality in livestock farming and social farming and apidology. And there's only these 3 courses, these 3 subjects that focus on social farming in the whole duration of the 2-year course. Other courses offered at tertiary level in Europe include the advanced training in social agriculture, which is offered at the University of Bologna, which only takes a duration of 3 months. And there's the practice support in social farming offered by the University Cork of Ireland, as well as the health and society course from the Wageningen University and Research. And there's 2 other additional courses from the same university, being international development and studies, as well as organic agriculture. And we also have multifunctional agriculture offered at the University of South Bohemia in Czech Republic, as well as the sustainable rural development course offered by University of Perugia in Italy. And from this table, we can note that there's quite a number of courses from Italy, followed by the Netherlands. And there's not too many courses available currently at the European level or in the rest of the world. There are other training opportunities apart from courses offered at the university level. There's also seminars, conferences, and webinars that are being held throughout the territory to educate people on social farming. And there's also online organizations that offer free training for social agriculture. One in particular is a training for social agriculture and territorial development, which focuses on a number of topics and trains people or farmers who want to go into the social farming. There's also a training program that was established in 2014 by an organization called Social Farming Across Borders, which is based in Ireland. And this training course was for 10 weeks. And they introduced social farming to whoever wanted to get into the social farming field and be prosperous in the field. There's also a training organization called the Sowing Gauge, which offers training support to farmers who want to join social farming by developing their knowledge to develop a professional service for the economic benefit and sustainability of both the farm and the rural economy. And this training module is based on real life case studies that are presented during the coursework. And now we can have a look at the evidence of social farming in practice. And it can be noted that from the works of Marau from 2014, there was a group of young people who were not in employment, education, or training, who were placed on a social farm for a time period. The target group was aged between 16 and above, who stayed on the farm for 3 months. And it was noted that the youngsters who were placed on the farm had improved interaction with their family, friends, and colleagues, and they had also improved self-confidence and self-esteem and exhibited calmer personalities to when they had arrived on the farm. there was also a group of 6 to 24-year-olds who were placed on a farm for a duration of 1 to 5 days per week for 2 years. And it was noted that the people had increased motivation to learn. They had improved social interactions and behavior, and they increased also their self-esteem and confidence. And they were able to find employment, and some were able to successfully complete their college years. Another group of students went on a school trip to learn more about social farming. And it was noted at the end of the study that they reported improved knowledge of agriculture compared to when they had first went on the school trip to a social farm. And in 2020, Flynn did a study in which mental health impairment, mentally impaired clients were put on a farm, and they were between the years of 16 and 19 years old. And in the study, they reported major improvement in self-efficiency on competency of the clients. And Berger did a study in 2008 and 2011, and they used psychiatry patients in this one. And the ages of the client were between 18 and 58 years old. And they stayed on the farm for a period of 12 weeks. And it was noted that they had improved drastically in their self-confidence. And in another study by Joy and Company 2020, it was noted that a group of people with intellectual disabilities who were placed on a farm for 6 months, and their age group was 20 and above, they exhibited signs of improved physical, psychological, and social functions. And another group of adolescents reported improved degrees of self-sufficiency and self-esteem. And a different group of learning disability clients who were placed on the farm for 4 months to 19 years, and their ages ranged from 18 to 50, improved their well-being drastically. And this study was done by Rotherham and Company in 2017. And there are 2 studies, PhD studies, that were published by Hambridge in 2017 and by Fell Chambers in 2020, respectively, who conducted their studies on a group of clients with ages 13 to 16. And they both noted that their clients had improved their personal and social functioning, personal development, and had increased engagement with the environment, and they had re-engaged with learning. And they also exhibited calmer behavior. They were motivated to learn and succeed, and they built relationships with other young people on the farm as well as the farm staff. And in conclusion, I can say that social farming has a positive effect on the mental health of different groups, irregardless of age. Spending time on a farm or interacting in nature is seen to be having a great output on the improvement of quality of life for a number of people, irregardless of the mental disorder that they are suffering from. A bit of time in the fields or a bit of time spent interacting with the animals or with the people in the social farm seems to be having a good effect on people in general, and also on people who suffer from mental disorders. But then with that being said, it can be noted that currently there's not many people qualified who receive training to be specialized in social farming work. And as such, more qualified personnel are needed to further the widespread of the utilization of social farming. And this lack of training need to be investigated, or it need to be fixed so that more qualified professionals can be introduced into this field. And with my concluding remarks, I would say education in social farming must be standardized, quality controlled, and popularized in all universities of the world for the greater benefit of the whole community at large worldwide. Thank you. And these are my references. Thank you.
Thank you, Sarah. Really an interesting overview of what happened now on the issue of the social, of the mental, of the social problem, and the social impact of the agriculture use in social farming. Again, well, many people are now attracted to this, and as you say, we need really to invest more in doing this for a benefit, and the society will benefit of it. Well, in fact, this is an issue from in terms of economic impact. What can be the benefit of such type of increasing such kind of training activities and promoting the development of social farming program in the different countries, starting from our country? So,
should I go ahead?
Yeah, I don't know if you understand my question.
Yes, I understand. On one of the slides that I presented from the OECD that show the economic impact of mental disabilities, that slide basically says the percentage was taken from direct or indirect costs. That being, when someone has mental disorders, they are not a functioning member of society, meaning they do not have a job. They have to rely on the government for grants, living grants. So if you were to introduce social farming and you take such people with mental disorders to a social farm where they can be taught how to manage their own lives, how to work properly, how to integrate into society and be functioning members of it, they can find jobs for themselves and not rely on the government. And as such, money that would otherwise be spent on them in terms of grants can be taken or used in other fields.
Mm-hmm. Well, but also maybe in reducing sanitary costs, because these people maybe also they need to be followed or maybe also treated with some kind of pharmaceutical things or hospitalization and so on. That if this is
going to an institution can cost way more than going to a social farm. On a social farm, you are working, you are contributing towards making some kind of profit for the farm, whereas in an institution, you will just be given meds and being taken care of without any benefit for the economy.
Well, I think that we need to convince our politician of this.
Yes.
And
the regulation is there. We just need towards getting more funding into the training part of it.
Well, I also see another issue, the competition with the medical sector, because they drain a lot of money. So I think that we should interact much more with the sanitary system in order to better plan all this activity together and avoid to be in conflict with these other structures that are already existing and active. But well, it's a very large issue. So good luck for your work in the next 3 years. Are there some other questions from the group, from colleagues?
Yes, I have a small one. It's not really a question, just a comment, because while okay, sorry, we have a return. Because, you know, while I was following the presentation, your presentation, Sarah, I had this, I don't know how to say, my feeling was to follow the wrong presentation. At the beginning, I thought we were at the medical school or something like that, you know?
Yes.
I mean, I know that to understand and also to study all these mental diseases or other problems that each person can have in terms of social and organic problem during his life or her life, it is so difficult to measure what happened, to understand what kind of disease we are facing on. You know, at the beginning, I was following your presentation and I thought, but I still in an agricultural department, or do we have change faculty, because to me it was a little bit, let's say, heavy, the part devoted to the presentation of diseases, the presentation of problems that apparently can be solved with social farming or agricultural, I don't know how to call this.
Social farming, yes.
Social, yes, social farming, and you know, I don't know how what it is, just to start with a understanding, because you know I had the feeling that it was a little bit moved toward what is for us far to be understood.
I understand. But from my point of view, to get to know what social farming is and what you can use with it, or how you can take advantage of it, so you can benefit a wider group of clients, you would need to have a background in what mental disorders are and the types of mental disorders and ways to go about helping people with mental disorders. If you have some kind of background in it, then you know your way forward. Now we know the problems that we are having with mental disorders. We can look forward to using social farming as a solution. But how do we use social farming, or where do we use it, and who do we use it for? Hence came the part where we had to elaborate a bit further on the mental disorders part, so as to give people a general background.
Well, no, I agree. I think that we are struggling with it. We want to go on this way. We need, I agree in the way that we need to understand what is the problem, what is the background. So we need to train people that have to work with such kind of, again, people that have different problems. So I think that it's good to know what are the problems and how to manage it. This is the reason why we also, in our case, we have courses from taken by colleagues from psychology and sociology, and also some such kind of topics. So the people, the students need to know why what they are doing and why they are doing this. Yeah, I don't know, Giuseppe, for me it was a good approach to give this introduction, but okay.
Okay, it was just
so, yeah, I don't know.
Thank you.
Okay, so thank you, Sara. And now we have the last presentation is from Leonardo Lori. I don't know if he's connected. Yes, hello,
yes,
Leonardo. So we have a presentation, natural hazard, vulnerability, and risk forest degradation.
You can see my presentation?
Yes, you can start with your presentation. Thank you.
Okay. Perfect. So, in the European Union, forests cover about the 38% of the total land surface, and of this 38%, the 95% of the forests are currently managed. In Italy, there is a similar situation with a forest cover of around 35%, but contrarily to the rest of Europe, they are currently largely unmanaged. All forests provide essential products and ecosystem services, as for example, on the picture shown below, we have the nature-based recreation opportunities that the forests create as an ecosystem services. So the European forests are, however, affected by natural disturbances that are mainly caused by the changing climate conditions that can increase the forest vulnerability to these disturbances and induce some risk to the forest and to the forestry sectors. According to recent studies, in Europe, the major disturbances that can cause timber loss are in decreasing ranking wind throws or storms that are the 40%, the fires that constitute the 34%, and the insect and pathogens outbreaks that are the 26%. We can see that there is, however, a different distribution of the disturbances in Europe, and we can see that in the northern Europe, the disturbances are mainly wind throws and bark beetles, while in the southern Europe, they are mainly forest fire. And recent research shows that the frequency and severity of these disturbances are expected to increase over time, as shown in the graph on the right. These disturbances are also present in Italy, and we have mainly the fire as a major disturbance, but especially in the Alps, we also can find windstorms and insect outbreaks that can cause broad impacts. There are also other disturbances, but we'll see later in this presentation. A major driver of as said before, a major driver of these disturbances is the climate change, and it can have three types of effects that are direct effects, as shown in the previous pictures, indirect effects that are, for example, the causing of the drought stress, or we can have synergic effects, as for example, the insect outbreaks that kill a standing tree, and that can increase the risk of fire and of tree fall due to the wind. And this can affect the vulnerability and increase the risk of ecosystem infrastructure damage. As said, we can have a synergic effect on the environment of these disturbances that can cause forest degradation and vulnerability. For example, we can say that wood decay, such defined caused by fire and insect, can increase the wind throws, and the wind throws can increase the insect outbreaks that can increase the fires, and so on in a circle. And all the disturbances can also increase the risk of slope instability. So we can now, through the presentation, I mentioned a lot of terms like disturbance, risk, vulnerability, and degradation. Now I'll try to make an explanation of these terms. So the climate change drives the forest disturbances that are wind, fire, and pathogens, and constitute the natural anthropogenic hazard. In addition to the climate change, the land use and cover change that can be defined as a land abandonment or a management withdrawal can increase the vulnerability of the forests and can cause with the increase of the disturbances, can cause the forest degradation that can involve change process that affects the characteristics of the forest, such as the structure, the productivity, and the functions. So we are in the area of risks, and we can enter in the forest degradation to prevent the degradation itself, with implementing the sustainable forest management that can be used to increase the resistance and resilience of the forests to the disturbances. There are different definitions of hazard and risk based on the field of study that we are in. We use the definition of Crichton's risk triangle, or the risk equation, that defines the risk as the probability of harmful consequences or the expected losses due to the disturbances, and the risk is affected, and its level depends on the interaction of these three factors that are the hazard, that is the potentially damaging effect itself, the vulnerability, that is the susceptibility to the harm, and the lack of capacity to cope and adapt of the forests to the hazard, and the exposure over time and space to the hazard itself. Vulnerability, but also exposure are important factors that can be affected by human activities and inactivities, as for example the land use change that can cause an increase in the forest and shrubland area, mainly due to abandonment and management withdrawal. And this is the case of a lot of areas in the Apennines, and can cause some ecosystem effects, like the increase of the vegetated cover continuity that leads to wood biomass accumulation that can lead to the increased risk of wildfires. In the Apennines, we have mainly the fire and wind disturbances of the three presented below before, and while the insect outbreaks are not a problem that affects mostly the Apennine area. So we decided to replace this disturbance with the slope instability that can be induced by the action of water in all its physical states. The disturbances can be independent or synergically, and that can affect the forest with a potential risk of degradation. In these two graphs, we can see a comparison between the fires and the wind throws, and how these two disturbances can be affected by a set of factors that can be common, exclusive, or different. The factor can increase or decrease the response of these two disturbances with a positive or negative response of the function to the variable. And for example, in forest fires, the biomass of the forest, the tree density, and the fire weather index, that is can be defined as the growth conditions of the stand, can increase the risk of fire, while the precipitation can reduce it. For the wind throws, in fact, landscape homogeneity and tree age, biomass accumulation, and also wind speed are all increasing factors. In fact, the wind speed is the main driver that can cause the wind throws. We can see that there are some factors that are common to both the disturbances, and this can partially explain why there can be a synergic effects of these disturbances. As we can see, biomass, tree age, and homogeneity are both present in the two graphs, and are both have a positive effect on the increase of these disturbances. We are now to see some effects of the forest fires, like in the Mount Morrone forest fire that happened in 2017 in Abruzzo, and that depended largely on the climate conditions that were in that time, but also by they were affected by the dense forests and the fuel accumulations that were present in the forests that were affected. We can see now some effects of the wind throws, as for example, that are mainly caused in the northern and central Europe by the landscape homogeneity of the forests. And for example, here we have the Vivienne windstorm that happened in 1990 and that caused a timber loss of 120 millions of cubic meters of wood. And to compare it with an other windstorm, that is the Vaio windstorm that happened in 2018, mainly in the northern Italy, we can see the difference as the impact was only on 9 millions of cubic meters of timber. So we can see while the Vaio windstorm was for Italy was an important disturbance, in fact, it was only 10 times smaller than the Vivienne windstorm or other windstorm like Gudrun that happened in the northern Europe. But wind throws can happen also on a smaller scale, and this is rather common on the Apennines with effects mostly in the conifer plantations, especially if they are not managed with appropriate thinnings. But they can also happen in coppices. For the last factor, the climate can affect the risk of soil erosion, but land cover, topography, and soil types can, with the proneness to erode of the soil, can influence the vulnerability of a specific area. And forest cover is less susceptible to the erosion than agriculture and urban cover, but the forest can sometimes cause some problems to the stability. While in the measure of the cases the forest increases the slope stability, we can have some effects due to the root systems of the species that constitute the forest structure, and the biomass weight that can sometimes create the possibility of shallow landslide due to roots, the superficial root system of a determined species, and also by the biomass weight of the population of the stand that is present in the area. Slope instability can and soil erosion can be studied with by different methods. As we can see in the image, the erosion risk is classified mainly according to the slope angles, and we can see that in the plains that are present in the northern Europe and in Pianura Padana, there is is classified as an area with very low risk of erosion, while in the Alps that are characterized by important slope angles, you can see that they are classified as at very high risk of erosion. But we can also study the landslide index that, in contrast with the previous map, is studied mainly with an historical point of view of the landslide that occurred in the past. So we can see that, for example, in the central Italy is somehow different because it is studied also by the point of view of the agriculture that can cause problems with the landslide. But landslide is also caused by landslide or effect on the soil erosion is soil instability. Sorry, is also linked by the, for example, snow and the avalanches that are also a factor that create instability. And we can see in the top image the snow avalanche that happened in Mount Caltria in 2012 on a mixed beech forest, and in the bottom picture we can see the sadly famous Rigopiano avalanche that happened in 2017, and we can see that while the forest can also be a factor that can mitigate the effects of these of the avalanches, there is still risk. For example, here we can see that there are some roads, forest roads, and we know that there was a high risk because there was a structure in at the bottom of the avalanche. So there were life losses, and we can enter, do an assessment of the risk with an integration of different methods that can be the remote sensing, that can be the satellite and airborne lidar images, or for example aerial photos, and that are an essential tool to study the risk. But we also need the field sampling that can be used to do a calibration and the validation of the data that we obtain with remote sensing, and both these methods are important to and contribute to the geostatistical modeling that can assess disturbance severity and the degradation risk prediction through time. Here we can see the assessment of fire ignition probability that was made by Vacchiano et al. In 2018 in Valle d'Aosta, and we can see that the ignition probability is higher in the areas that are highly where there is a high presence of human activities and cities, which can explain why a lot of the fires happen in Italy. We can also and mostly use these methods in a multi-spatial temporal scale that uses remote sensing, mainly in the regional scale and in the landscape scale, while the field measurements can be used on the stand scale, with the contribution of new technological instruments, such as the one that is presented in this image. To conclude, I'd like to point out how my PhD doctorate enters in this framework that I presented just now, with the aims to determine the vulnerability to these three main disturbances that are forest fire, wind throws, and slope instability in the forest of the Marche region, and to define a quantitative methods for risk level assessment of forest degradation, especially if they are affecting public and private safety. We can say that the ultimate goal of my PhD is to try to provide guidelines for an appropriate sustainable management, especially in the silent forests that are so defined by national and regional forest regulation. They define silent forests as forests that are abandoned and of which we cannot find the owners, and thanks to this regulation, we can enter in this forest and do possible management in case of public and private safety. Here I have a list of the references used for this presentation, and a list of the websites that were used to get some images, but also some information to the realization of this seminar. Thank you for your attention.
Thank you, Leonardo, for your presentation. Well, good definition of risk. Well, just my very fast question. Well, in my case, I was used to define risk as other than exposure. You included vulnerability, so it's an additional thing that probably is specific for your work. But among the three things, what is more easy to detect and to expect in some way? So, or maybe other and exposure can be enough as usually we apply for the risk assessment.
Yes, as said, there are many definitions of risk. In this case, I use this that is characterized, so as said, by the hazard, the vulnerability, and the exposure. The vulnerability is important because it characterizes the susceptibility of in this case forests, but that can be also of infrastructure, cities, or other things, and also probably the easiest factor can be maybe, I don't know, exposure, probably, because it's mainly characterized by an historical definition and study of the problem, but we can also expect the vulnerability, for example, in the cases that we don't have a forest management, and with the increase of all the problems explained before, like the increase of forest cover, that is some way a positive effect, but can be a negative effect if it is not managed well, and can create, as said, problems with the risk, and also probably mostly with risk to public and private safety. That is the most important factor.
Yes, I agree. Thanks. That's really important. I don't have other curiosity or question. I don't know if colleagues have curiosity or question. Some other people that are more near to, again, I'm far also from from the topic of your seminar, so it was just curiosity. Okay, thank you, Leonardo. Let's stop here today's section for the PhD seminar. I think it was very good as a first day. All presentations were very interesting and well prepared and presented. So I asked my colleagues to send me back by email the evaluation, the file, the evaluation form that I sent out. And okay, let's be connected again. So let's keep the connection, this system, online system, for the next week. So next June 10 at the same time, and we will have other 5 presentations. Okay, thank you very much to everybody. I will try to save the recorded version of the today presentation, and it maybe I will publish it on the web. Adele, ciao.
No, ciao. Thank you, thank you. See you.
Dimmi, è andata bene?
Sì, benissimo, benissimo direi.
Ok, dai. Andiamo avanti online, penso che sia meglio per tutti, o perlomeno io mi sento più anche tranquillo nel dover organizzare le cose in aula. Quindi ci vediamo la prossima settimana collegati online. Sempre lo stesso link, se non lo trovate è ora disponibile sul sito, sulla pagina del Dipartimento, sulla pagina dottorato, seminari, e lì trovate sempre il programma e il link per ricollegarsi la prossima settimana.
Ok, Bruno, scusa Carlo.
Sì.
No, io purtroppo mi sono collegato solo poco fa perché avevo lezione fino alle 4 di fatto, anzi 4 e mezzo, ho anticipato un po'. E quando saranno, perché io non avendo visto i primi 4 non avrei elementi di valutazione, la registrazione è già disponibile, nel senso che sì,
la scarico adesso.
La stai scaricando, ok, perfetto, quindi do un'occhiata a quello e poi entro fine settimana, può andare bene? Domani sono fuori in campo.
Sì. Quando me lo mandi, per lo tanto
va bene.
Diciamo così che dedicherò un pomeriggio alla settimana di dottorandi ormai per le prossime altre 4 o 5 settimane, quindi siamo qua.
Ok, va bene, grazie mille, grazie a tutti, ciao.
A tutti, ciao, buona giornata a tutti, buona serata a tutti.